So here we have the vector A and the vector B, which are shown on the grid. And we have the grid here, so we have a kind of graph set up with the x-axis here and the y-axis here. And then we have the two vectors, so this vector A going in this direction and then the vector B going in this direction here. And we're asked to, on the grid, draw and label the vector of -2a. So firstly here, I know that I'm going to be working with the vector A, and I'm going to be working with -2 lots of this vector. So if I have a look at vector A here, now if I want to work out how to work with vector A, it's going to be useful to write vector A in some kind of numerical form so that I can represent it here and multiply it by this magnitude of -2. So if I have a look in the x-axis, from this point to this point, there has been an increase in 1 in the x-axis, so this increase in here from 3 to 4. So if I write this as a column vector, I can take this x value as an increase of 1. And similarly, in the y-axis, we've gone from this point here to this point here, so there's been an increase in 2 squares in the y-axis. So 1, 2 is this vector A as a column vector. Now to find a -2a, which is what I need to draw on this grid, I simply need to multiply the vector A by -2, and I can just multiply both the top and the bottom of this column vector by -2 because -2 is just a numerical value here that I'm scaling this vector by. So -2 multiplied by 1 is -2, and -2 multiplied by 2 is -4. So now I have the vector of -2a, and I can draw this anywhere on the grid here because this is a vector, it's just showing direction and magnitude, it is not from a certain place. So for example, I could start at this point here, and I now need to go 2 along in the x-axis, -2 back from this point, and then -4, so 4 down to this point here. So I can just connect these two dots up with this line, and I need to make sure I label the vector, so I'm just going to draw the arrow of the direction because we're going -2, -4, it's going to be downwards, and I can label this as the vector -2a here to gain me the mark. So here we're asked to work out a plus 2b as a column vector. So when I'm working with adding together these vectors to create a plus 2b as a column vector, well, I could simply work out what a and b are as column vectors themselves, and then I can just add 1 lot of a and 2 lots of b together in order to get this value of a plus 2b as a column vector. So similarly to the previous part of the question, if I want to find the column vector of A, which I did do before, column vector of A is going to be, well, to get from this point to this point, we see we go an increase of 1 in the x-axis and then this increase of 2 in the y-axis. So that's a column vector of 1, 2, so xy is 1, 2. And then for B, I can do the same thing. So to go from this point here down this vector to this point, there's been an increase in 1 in the x-axis, and then there's been a decrease of 3 squares in the y-axis. So B as a column vector is 1 minus 3. Now I can use these values to work out a plus 2b as a column vector. So I can just take the value of A, which is 1, 2, and now I need to add on 2 lots of B, which is 1 minus 3. Now, because I'm just working with a number multiplied by a column vector with this B part here, you can simply multiply both the top and bottom of this vector by this 2 in order to work out this value. So in effect here, I have 1, 2 plus 2 lots of 1, which is 2, add 2 lots of -3, which is -6. And then working with adding column vectors, I can simply add these x values at the top and the y values at the bottom to get this answer, So I have 1 plus 2 gives me 3 at the top. 2 plus minus 6 is 2 minus 6, so that gives me minus 4. And that is going to be the correct answer here for the column vector of a plus 2b. So as for how both of the marks are awarded, the first mark would be for kind of writing out this attempt to add this a plus 2 lots of b, and then the second mark would be for this correct final answer here of 3 minus 4 as the column vector.